Let's start with exponents and roots. It's one of those formative topics that are useful in many questions. Let's jump in. Exponents are just a concise way of showing multiplication. So if I were to write, let's say 2 into 2 into 2 into 2 4 times, it's quite cumbersome. And think about what happens when it goes to 2 into 2 into 2 10 times. So then it's easier to write 2 to the power 4. This just means that 2 is multiplied to itself 4 times. Now we'll learn a few rules, but remember this is the very basics of exponents. And if you do, then really you don't really need to learn these rules. They will be quite obvious to you once you understand that exponent is nothing but multiplication. So your rule 1 says a to the power m into a to the power n is a to the power m plus n. Let's take a quick example to understand this. Let's say we have 2 cube into 2 square. What is this going to be? These are 3 2's and we also have 2 2's. So in all, we just have 5 2's multiplied with each other. So when your base is the same, then your exponent gets added. The two exponents will get added because you open them up and you see that these are all just multiplications, right? So 2 is multiplied with itself 3 times and 2 is multiplied with itself 2 times. So overall, we get 5 2's. And that is why the exponent gets added. Now, a to the power m upon a to the power n is a to the power m minus n. Again, think about it. You have 2 cube and you have 2 square. This is 2 into 2 into 2. And this is 2 into 2. Of course, 2 2's get cancelled and all you're left with is 1 2. So what happened? Basically, the bases got subtracted. So 3 minus 2. Of course, in case this were instead 2 square upon 2 cube, then this will be 2 to the power 2 minus 3. That is 2 to the power minus 1. We'll just look at negative exponent also very soon. Now, a to the power m, the whole thing to the power n, then the exponents get multiplied. Now, think of it, this is 2 cube square. So now, the entire 2 cube is squared. That means 2 cube is multiplied with itself twice because the entire 2 cube is squared. So then we have 3 2's here and 3 2's here. So overall, we have 6 2's now. So basically, the exponents have gotten multiplied. So we get 2 to the power 6. Now, for any number a other than 0, because 0 to the power 0 is not defined. But for any other number, a to the power 0 is 1. So 2 to the power 0 is 1. 3 to the power 0 is 1. Minus 2 to the power 0 is 1. All of this is 1. Okay, a to the power minus n is 1 upon a to the power n. So we looked at the negative exponent over here. This is how we deal with the negative exponent. A to the power minus n. This is actually 1 upon a to the power n. So let's say if I have 2 to the power minus 1, this is 1 upon 2. If I have 2 to the power minus 3, this is 1 upon 2 cube, and so on. And then if I have, let's say 1 upon 2 to the power minus 3, I can write this as 2 cube. So when the exponent goes from, when the term goes from the numerator to the denominator, then it gets a negative exponent. It's basically the sign of its exponent flips. And when it goes from the denominator to the numerator, again the sign of the exponent flips. So if it is positive in the numerator, it becomes negative in the denominator. If it is positive in the denominator, it becomes negative in the numerator. If it is negative in the denominator, it becomes positive in the numerator. I hope you understand this. Basically, the sign flips. When the term flips from numerator to denominator or denominator to numerator, the sign of the exponent flips. All right. Now, a to the power n into b to the power n, when the bases are different, but the exponents are the same. They're both n in this case. So let's say 2 cube into 3 cube. Now the bases are 2 and 3, which are different, but both have the exponent of 3. Essentially, this is 2 into 2 into 2 into 3 into 3 into 3. Since the exponents are the same, we can say that this is 6 into 6 into 6. So this is 6 cube. So what happens is that the bases get multiplied. And then we have the same exponent n. What about a to the power n upon b to the power n? Again, assume this is 2 cube upon 3 cube, which is nothing but 2 by 3 to the power 3. If you're not sure, just think of it this way, right? 2 by 2 into 2 into 2 upon 3 into 3 into 3. So this is nothing but 3 2 by 3's multiplied with each other. So this becomes 2 by 3 cube. So when you have a to the power n upon b to the power n, it becomes a by b to the power whole to the power n. Let's take an example which uses all these rules that we've just discussed. So given that 2 to the power 5n, okay, so I'll write it down here for you. 2 to the power 5n into 4 into 3 to the power minus 3 into 3 to the power m upon 8 to the power n into 3 square is equal to 4 to the power minus 2 into 243. Okay, first of all, we know that we have a lot of rules, but they're all based on having the same bases with different exponents or having the same exponent with different bases. So since we know that 4 is 2 square, 8 is 2 cube, we do see that we'll have a lot of common bases over here. So let's convert everything to base 2. So this becomes 2 to the power 5n into 2 square into 3 to the power, okay, let's use the rule minus 3 and m, 3 to the power minus 3 into 3 to the power m. So this is a to the power m into a to the power n. So the exponents will get added. So 3 to the power minus 3 plus m. Yeah, okay, let me just erase this to ensure that there is no confusion. So this becomes minus 3 plus m. The exponents get added. Upon, we have 2 cube to the power n into 3 square. Let's just work with this only as of now. So this becomes 2 to the power 5n plus 2. Here the bases of 2 are common, so then the exponents will get added. So 2 to the power 5n plus 2 plus, now here we have 3 to the power some exponent upon 3 square. So then 3 to the power a upon 3 to the power b is 3 to the power a minus b. The exponents get subtracted. So of course it's not plus. It's multiplication. If it were plus, then we would not have been able to do it. And we'll just discuss over here what happens in case of addition subtraction. So this becomes 3 to the power minus 3 plus m minus 2, right? Over here, we used our rule of the same base but different exponents when they are divided upon 2 to the power. Now 3 is multiplied with n because the entire 2 cube is taken n times. So we discussed that when we have a to the power m, the whole to the power n, that is basically equal to amn. So this becomes 2 to the power 3n. Now this becomes, now here the bases are the same, they are 2. So now we can divide, we can subtract the exponents once again. So we get 2 to the power 5n plus 2 minus 3n, which is 2 to the power 2n plus 2 into 3 to the power m minus 5. Now let's look at the right hand side as well. The right hand side is 4 to the power minus 2. So we can write it as 2 to the power 2 and the whole thing to the power minus 2. These exponents will get multiplied as well into 243 is nothing but 3 to the power 5. So this becomes 2 to the power minus 4 because the exponents get multiplied once again using this rule and into 3 to the power 5. Now we are given that m and n must be integers, right? So then the exponent of 2 on this side should be equal to the exponent of 2 on this side. So we have to say that 2n plus 2 must be equal to minus 4. So n must be equal to minus 3 and m minus 5 must be equal to 5 because the exponent of 3 over here should be equal to the exponent of 3 over here. So m must be equal to 10. Now the question is, what if we were not given that m and n need to be integers? Then can we say that 2n plus 2 should be equal to minus 4 and m minus 5 should be equal to 5? Not really. Why? Because we have one equation and two variables. I can give any value to n and I'll get a corresponding value of m, and it needn't be an integer, so it could be anything, a fraction or even an irrational number or whatever, and it doesn't matter. Like for example, if over here I was to say, okay, so then this equation must hold, right? This equation. Let me put n equal to 0. So then what do I get? I get 2 to the power 2, which is 4, into 3 to the power m minus 5 is equal to 2 to the power minus 4 into 3 to the power 5. So then I have a 2 here. I have a 2 to the power 4 in the denominator here. I'll bring it over here. I get 3 to the power m minus 5 is equal to 3 to the power 5 upon 2 to the power 6. Now I will have to use logs, but I can find the value of m. Well, it will not be an integer, but it doesn't matter. If we are given that m, if we are not specified that m and n have to be integers, then it's fine. Then m can take any value and I can put any value for n. We have two unknowns and we have one equation. So then we cannot find the values of m and n only because we were given that both need to be integers. Then their exponents on both the sides need to match. For these bases, the exponents then need to match. Okay, what happens if the terms are added or subtracted? For example, if I have x is equal to 2 cubed plus 2 to the power 4. Now, is there any rule about the plus over here? What can I do? Can I say that this is the same base and we add the exponents or subtract or something? Well, no. In case of plus or minus, we don't have any rules given to us. The only thing we can do is we can take something common. We know that exponent is nothing but a multiplication. So x is equal to, and we can take 2 cube common from here. We are left with 1 plus 2. So this is equal to 2 cube, which is 8, into 3, which is equal to 24. Please remember, there is no rule for plus or minus. The only thing we can do is take common. So assume, let's say a question like this, 2 to the power x plus 2 to the power, say, x minus 1 is equal to 12. How would we solve this? Again, we cannot take the base common. We cannot apply any rule. We have to only take common. So here we have 2's x times. And here we have 2's x minus 1 times. That means we have 1 less x as compared to over here. So then what can we take common? We can take 2 to the power x minus 1 common. We have 1, 2 left plus 1. That is equal to 12. So since this is 3, we get 2 to the power x minus 1 is equal to 12 by 3, which is 4. And if it needs, and then this is what? 2 square. So now, anyway, now there is no other possibility because now we have 2's as bases on both the sides. So for them to be equal, the exponents must be equal. So now x minus 1 must be equal to 2 and x must be equal to 3, right? Please remember, that in case you have a plus or a minus between your terms, you cannot apply any rule. The only thing you have to take is take common. That's all. Okay. So now let's take a look at polarity of bases. What is polarity of bases? So for example, if I have 2 and I put it to any real power, for example, I put it to 4, or I put it to 1 by 4, or I put it to -4. Is there any way in which I can convert it into a negative term? This is a positive term no matter what the power. This is a positive term again no matter what the power. Now, don't get confused again. Don't think that 2 to the power half is root 2 and it can be a plus or a minus root 2. No, when I'm saying it is to the power half, I'm assuming it to be the principal root. So this is just root 2. Yeah, then 2 to the power -4 is 1 upon 2 to the power 4. So is there any way, can I take it to any exponent such that it becomes a negative term? Well, no. If the base is positive, then the term must remain positive no matter what. But if the base is negative and we have an even exponent, then the term will become positive. If we have an odd exponent, then the term stays negative. Okay. So that is why then it's a little harder to predict what happens when A is negative, because it can be positive or negative, the overall term. So let's assume, let's say if we know that we have A positive. So, and we raise it to a certain power. When A is between 0 and 1, what happens? So I have 1 here on the number line, I have 0 here. When A is between this, is between 0 and 1, if n is positive, if n is greater than 0, and A is between 0 and 1, then A to the power n is between 0 and 1. So what do I mean by this? Let me take A as half. So if n is greater than 0, that means let's say I put it to the power 2. What do I get? I get 1 by 4. So A to the power n stays between 0 and 1. When it is between 0 and 1, whatever exponent I give it, as long as the exponent is positive, then it stays between 0 and 1. If the exponent is 0, then of course we know that it goes to 1, because we know A to the power 0 is always 1 if A is anything other than 0. And then if n is less than 0, if we have a negative exponent, so let's say if I have half and I raise it to the power -2, what happens? So this is essentially 1 upon 2 to the power -2, which is 2 to the power 2. So then A to the power n becomes greater than 1. When my base is between 0 and 1, if my exponent is a positive number, then it stays between 0 and 1. But if my exponent is a negative number, then the term becomes greater than 1. Now, you don't have to learn this up. It is something you can easily derive in a question. Just be aware that these relations exist so that you know what to do. You know how to derive, right? Now, when A is greater than 1, that is when the base is greater than 1. Let's say when A is 5. If n is greater than 0, so let's say is 2, then it stays greater than A to the power n stays greater than 1. Initially, A is greater than 1. When n is positive, then it stays greater than 1. Here, it was between 0 and 1. When n is positive, it stayed between 0 and 1. If n is 0, of course, then A to the power n goes to 1. We know that. Now, if n is negative, then the term goes between 0 and 1. So now look at this. If I say 5 to the power -2, then what happens? This becomes 1 upon 25. Now it has gone between 0 and 1. So think of it this way. When my A lies over here, when n positive, A continues, the same state continues. When A lies over here, when the exponent is positive, the same state continues. When the exponent is negative, then if a is between 0 and 1, the term flips and goes to greater than 1. And if a is greater than 1, the term flips and goes to between 0 and 1. So think about it. If I have a positive number, no matter how many times I multiply it with itself, it'll never become negative. Even if I raise it to a negative exponent, it'll just flip, it'll become its reciprocal, but it will still not acquire a negative sign.